So today we're going to look at section 2.2, same section as yesterday, just part 2. And what we're going to focus on is finding the 6 trig functions of those 3 angles. And really, once we know how to do these 3, then we pretty much could do anything on the unit circle that we're going to have to do. We're just going to focus on those 3 for today, but I'll kind of show you a little bit of what we're going to do tomorrow. And I think it'll make sense after we go through some stuff from today. All right, so let's just take a look at where 45 degrees is on the unit circle. Okay, so if you got your unit circle. Okay, unit circle means the radius is how much? 1. It's 1 unit in every direction. Okay, if that's 0. Yeah, it's coming down.
That's how it is.
Yeah, because it's a metal roof.
Someone whipping the laptop.
So we got 0, we got 90. Where would 45 be?
In the middle.
Yeah, right in the middle. That's 45. So what we have to figure out is the coordinates for 45 degrees. Because remember, that's what you need to do unit circle trig. You got to have the coordinate. So if you start at the origin, the x value is how far to the right you move. That's your x. And the y value is how far up. So we need to figure out the lengths of those 2 things in red. Now, if I add in one more line segment, I could basically turn that into what shape? A triangle. I could turn that into a triangle. And that line in black, I know the length of it because it's the radius. It's the distance from the center to the edge. How long is that line in black?
1.
It's 1. Unfortunately, that doesn't directly give me the coordinate, but it'll help me get the coordinate. Okay. Now, because this is a 45 degree angle, that's a 90. All the angles in a triangle have to add up to 180. So what does that angle at the top have to be?
45.
It's also a 45. So now, if we have 2 angles that are the same, what does that mean about the sides?
The same.
X and Y are really the same length. So what we're going to do is when we figure out how long they are, we're just going to use the same letter. Okay, we don't have to use 2 different letters. All right, but that's the goal, to figure out what's going to go in that box. Okay, we don't know what goes in there yet, but whatever goes in for the X is the same thing that goes in for the Y. Okay. All right, so let's go back and figure this out. So this is the same diagram. If you already drew it, it's the same diagram again. I just drew it a little neater. And here's my 45, 45, 90 triangle right there. And I put it bigger off to the side, okay, because it's easier to work with if it's bigger. Now, since the sides are the same, let's just pick one letter and use it for both sides. Okay, so what do we want to use as our letter?
X.
X, sure, we'll just use X. So if that's X, that's the same thing. That's also X. Now, there's a theorem from geometry we can use that we can figure out the length of the sides in a right triangle. Does anyone remember what that theorem is? Yeah?
Pythagorean Theorem.
Yeah, the Pythagorean Theorem. So we can use that to figure out X. What's the Pythagorean Theorem, Eric?
A squared plus b squared equals c squared.
Now, I don't have any A, B's, or C's up here, so can you explain to me what's A, what's B, what's C?
A and B are the x's,
Yep.
and then c is the 1.
Exactly. A and B are the legs. They're the 2 short sides, which in this case we're calling them X, and C is the long side. It's the hypotenuse, and we're labeling it as 1. So let's fill in what Eric just said into the Pythagorean Theorem. So we have one of the shorter sides squared plus the other shorter side squared equals the hypotenuse squared. All right. So now we've got x squared plus x squared. Joe, what do you get if you have an x squared plus another x squared?
2x squared.
2x squared. Yep. Just combining like terms. So 2x squared equals 1. And now the goal is to get No, it's someone's cell phone.
Yeah,
The goal is to get x by itself. Probably a ring warning. Don't go outside. I'm sure life jacket. All right, what can I do? What can I do to get x by itself? I got to do two things. I got to get rid of the 2, and then I got to get rid of the exponent. Which one do I get rid of first?
No, 2.
Let's try the number in front. We'll do the exponent last. How do we move that 2 over to the other side? Divide by 2 and 2. So now we're getting there. I'm just going to go over here because I don't have much more space. X squared equals 1/2. Now, if we do one more step, we will have x equals. And that is going to help us to figure out our coordinate. That's going to be the 2 numbers. So what's my last step? A coordinate?
Square root of both sides.
Yep. And when you square root a fraction, you just do the top of the fraction and the bottom of the fraction. That's how you square root a fraction. So that cancels. And we get square root of 1, that's easy. Just 1 over the square root of 2. So we had problems yesterday in the notes that had a lot of square roots of 2 in them. This is where the square root of 2 came from. Square root of 2 always has to do with a 45, 45, 90.
Didn't you say for a number that can't be square root on the bottom?
Yeah, we don't want to leave the square root in the bottom, so how do we fix that? And once we fix it, now you're going to see a number that you saw yesterday. Yeah, that's good. Multiply the top and bottom by the square root of 2, and now go straight across. 1 times the square root of 2, divided by square root of 2 times square root of 2 is square root of 4, which is 2. And that's a number we saw a lot yesterday, root 2 over 2. So, now we know that the length of the bottom side, we labeled it as x, but x is the square root of 2 over 2. So you have to go from the origin to the right, square root 2 over 2. If you wonder, well, how long is that? Well, that's the square root of 2. Divided by 2, it's about 0.7. Okay, we're not going to use that number ever, but if you just want to know how far over did you go, 0.7. And then how far up did you go? Well, it's the same thing. Square root 2 over 2. So, just kind of take the last step and write the coordinate. Anyone think they can tell me the coordinate for 45 degrees? Joe?
Square root of 2 over 2 is square root of 2 over 2.
Okay, square root of 2 over 2. Perfect. So that's the coordinate for 45 degrees. And that's one that you gotta memorize. So that way, if you memorize it, we don't have to go through and figure it all out again. Could you if you had to? Sure. You could go through the Pythagorean Theorem and figure it out again.
So if it was asking what the, what's it called? Oh, it's coming.
Well, it's going to ask you something like this.
Nah, yeah, I just got like one word that I'm trying to think of. And,
I want to say it for
yeah, like start to,
That's what it's going to ask.
So it's gonna know.
Nah, like I get that. I get that.
That's all you have to know how to do.
No, yeah, I know that. But
Yep.
So that's the same for every unit.
It's always root 2 over 2. Yep,
So
never
that, if it's
changes.
asking that, literally we can just go straight ahead and write.
We
root,
can't
like,
use a
square root
reference
2 over 2.
paper on the test.
Not for
Because
this
that's
one.
X and Y also.
Yeah, you can just write it down. You don't have to ever figure it out again. Yep. So this problem, it says find the 6 trig functions of 45 degrees. What's the first thing you should write down about 45 degrees? The x and y. Just right away. You don't have to show me how to get them. If you can remember, it's just root 2 over 2. You just write it down. Okay. So write down the coordinate. Any questions on where we get the coordinate from for 45 degrees? That's what we just went through. Now, from here, this was a problem in our notes yesterday. We already did this problem. I think it was example 2, if you look back in your notes. We'll go through it again, but the only difference is this time you had to write the coordinate. I didn't give it to you. So let's start with the sine. Okay, what would the sine be? And since they're the same, can you just tell me which one you picked so we know?
The y.
Yes, the y. So square root 2 over 2. Again, if you switch the x and the y, you'd be okay this time, but usually you're not. So sine is root 2 over 2. Christian, the cosine?
The cosine would be root 2 over 2. Right?
Yep, that's also root 2 over 2. And again, these aren't numbers I memorize. I don't have, I mean, some of these I have memorized, but in general, if you just ask me something on the unit circle, I always have to think about it in my head. I think about the coordinate, and then I go from there. That's the only thing that I have memorized, the coordinate.
We should remember this for the test.
Yep, you should remember root 2 over 2. I would not try to memorize all 6 of these. That's a waste. Don't memorize the sine, the cosine, the tangent. You memorize this, you automatically can figure any one of them out. Does that make sense?
Yeah.
You just memorize that one coordinate, root 2 over 2, root 2 over 2, and you're good. And you'll be using it a lot today and tomorrow, so eventually it'll just, hopefully you'll remember it. Tangent.
Is that like square root of 2 over 2 over square root of 2 over 2?
Yep, it's square root 2 over 2 divided by square root 2 over 2, dividing two things that are the same. So what do you get?
1.
1. Yep. And now, once you have the 3 on the left, what do you do with them to get the 3 on the right? You do what?
Flip them.
Flip them. Yeah, just flip them. That's why, again, I don't memorize what they are. I just remember, okay, I got the 3 on the left. Just flip whatever I see. Okay. That's the quickest one. Now, does anyone remember what root 2 over 2 is when you flip it? If you remember it, you don't have to go through it all. We can if we need to. But yep, it's just square root of 2. Does anyone want me to, we did it yesterday, but anyone want to see it again?
Yeah, actually, can you do that?
So when you do it, you start with this, right? That's what you get when you flip it. And now you've got to multiply top and bottom by square root of 2. So you get square root of 2 over square root of 2. And now go straight across. 2 square root 2 in the top. And then in the bottom, it's square root of 2 times the square root of 2, which is the square root of 4, which is how much? 2. And then look at what's in the top and what's in the bottom. They cross out. That's going to happen every time. So now whenever I see root 2 over 2 and someone says flip it, I just say, oh, it's root 2. Because I know it's always going to be root 2. You don't have to memorize it, but it's a little quicker if you know that. And this one's the same. Okay. Why is secant the same as cosecant?
Because x and y are the same. And
Yeah. X and y are the same. They're flipping the same thing. Okay, so that was example 2 from the notes yesterday. The only difference is you had to know the coordinate first. Okay. Any questions on that one? All right. So let's look at the 30, 60, 90 triangle. So there's 2 triangles you need to know to do unit circle trig. 45, 45, 90. And the coordinate there is always root 2 over 2. And then this triangle. And once you know this one, that's all you need to know for the rest of the week. Except how to use a calculator. You need to know that too. But that part's easy. Yeah.
Wouldn't this, if you're finding out 30 degrees and 60 degrees, wouldn't you do the same thing but just flop the x and the y coordinates?
Yep, exactly. So once you know the 30, you automatically know the 60. They're just switched. Yep, because I'll draw it out so people can see it, but yeah, I was going to mention that a little later. Yeah, that's good. All right, so it's not perfect, but that's about 30 degrees right there. Okay, it should be about a third of the way towards 90. 60, well, we'll do that one after. So here's 30. And I've taken that triangle and I've just drawn a larger version off to the side. So 30 degrees, that's the smaller angle down here. And 60, well, that has to be 60 because all the angles have to add up to 180. So We got 90 in the corner, 30 between the x-axis and the hypotenuse. That 90 and 30 adds up to 120, so that leaves 60 left for the angle at the top. Now, one of those sides we already know.
Is the inner angle always the same as the outside? Like 30?
Like this one and this one?
Yeah.
Nope, those are different.
No. So you wrote 30 on the outside. Is it always?
Yeah, 30 is just the marking on the circle. Like I could put 180. Yeah. This angle right here should match that right there.
It should always match.
Yeah, because that's basically, think of the hypotenuse as what you're pointing at. You're pointing at the 30. So that means like if this was like a cannon or something, you just elevated it 30 degrees. Or if you pointed it straight up, the cannon would be at 90 degrees. Yep. Okay, now which side in that triangle do we already know how long it is?
The hypotenuse.
Yep, we know the hypotenuse, which is how long? It's 1. Now, is that an isosceles triangle like the last one?
No.
No. So, because it's not isosceles, what does that mean? Yep, Corey?
It doesn't have two the same size.
It doesn't have two sides that are the same. These two sides are different. The side that's 60 is longer than the side that's 30. Now, from MCAS, there are these two triangles are on that test, so it is something that it's on a reference sheet. But let's assume we don't remember, and I'm guessing most people don't remember the triangle from that reference sheet. Does anyone remember it? Yeah.
What type of triangle that is?
Well, on the reference sheet, it has these sides already labeled for you. But I'm guessing most people don't remember what that says. Well, it is scaling, but the reference sheet has the actual numbers on it.
Oh.
So like some people might have it already memorized from that, but I'm guessing probably not. All right, so we don't want to do this. So don't do this. The problem with that is it's labeled accurately, but how many variables do I have there?
2.
2. So if I plug that into the Pythagorean theorem, now I have this. Well, that's a problem because we have 2 variables. You only can have 1 to make that work. All right. So if we're going to use Pythagorean theorem, which we can do, we have to figure out one of those letters, either x or y, a different way before we use Pythagorean theorem. And there's a trick. It's kind of something visual I'm going to draw. It's a little tricky to figure out. Yep.
Isn't the small line twice as long as Isn't it half as big as the long one?
Yes, if you knew that, the short side here that goes up and down is always half as long as the hypotenuse. That is a fact if you knew that about 30, 60, 90s. And then you would know this side is 1/2. I'm going to show you how to figure out this side is 1/2, even if you didn't know what he just said. But that is true. Yep. Does anyone know how to figure out the short side without knowing what he just said? Okay, it involves making a copy of this triangle. So let me just group all that together and make a copy of it. And I have to place it a certain way. Does anyone have a guess how I could place that? There's a few different ways you can place it, but there's not that many.
View the short side on the as a base.
Use the short side. So where do you want to put this one?
I don't really get what you mean. Are you saying inside of the circle? Where are we placing it?
No, it's going to be attached to this triangle somewhere. You know, like it's.
Oh, I don't know. Flip it so it's like.
Flip it?
here, kind of.
There's 2 ways I can flip it. Like flip it that way.
No.
No. All right, let me put it back. Flip it that way.
No.
That's the only 2 ways I can flip it.
If you like turn that a little bit.
There's definitely more ways to
You
do
can
it.
actually rotate it or mirror, you know?
I can rotate, but those are the only 2 ways you can flip it.
I don't know. Wait, yeah. Can you rotate it now?
I can rotate it.
Nah, other way. Keep it that way.
Not
Okay,
that
yeah,
close.
not too far.
Too far?
I guess actually, yeah. Put them back to back.
Back to back.
No, not that one.
Like that. I was kind of talking like wrong side or some shit, but like.
So the long side to the long side.
What? You guys laughing? I'm taking a guess. You guys start guessing. I don't know.
So-
long side to the corner. I don't care.
That would be long side to long side.
I was thinking
Looks
like
like whatever. I was thinking like longer side to longer side. Like I like.
Oh, like making a rectangle out of it?
Yeah.
So you'd have it.
That's what I meant by flip it earlier.
Okay. You could try that. So if you put it like over here.
I don't know. You want to stack those things like the rocks you see at the beach. Toss a corner to a corner.
What did you dodge?
There's so many ways these can go together, and I'm the only one that's saying stuff.
Well,
You want to say they can go together? I don't know.
I agree. You gotta stack them together. Let's try it this way.
Points.
If you look at what I just made there.
Favorite.
What do I have? Well, what shape did I just make?
A triangle.
A bigger triangle. What kind of triangle? An equilateral. That's important. It's equilateral because this is 60, 30 and 30, 60 and 60. So what does that mean? An equilateral triangle, what's special about that? Yep. All angles are the same. And all the sides are 1. So 1, 1, and this side is 1. So now, if that entire side is 1, we know that this side and this side have to be the same length, right? Because they're copies of each other. Right? So if these two sides are the same length, and they add up to 1, then they both have to be what? They both have to be a half. And now we figured out one of the sides. Without using Pythagorean Theorem, now we can use it and we're good. Right? So it's just kind of a little trick. Like if you didn't know the fact Joe said that this side is half as long, if you just flip it and make an equilateral triangle out of it, you can figure it out, but it's a little tricky to think of that. Now we don't need the bottom part anymore. Okay, so we're done with the bottom part. And now we've got the hypotenuse is 1. We've got the short leg is a half. Now, do we know the bottom side?
Yeah.
I mean, do we have a number for it yet?
1.
It can't be the same as it has to be shorter than the hypotenuse. So, but do we have the exact number yet?
No.
No. So for now, let's just call it x. And once we figure out what x is, we never have to figure it out again. We have it. I think the easiest way is to just keep it memorized, and then you never go through the Pythagorean Theorem again with this. So now let's plug into the Pythagorean Theorem. How about Chris? Could you read answering a lot of stuff? How about Eric? Yeah, you're off the hook. You did well. Can you fill these numbers into the Pythagorean Theorem for me?
So the x would just be x squared.
Squared.
Plus 1/2 squared.
Yep.
Equals 1.
Squared. Now, how many letters do we have in that?
1.
Just 1. Perfect. If we did it before, we had 2 because we didn't know the 1/2. Now we just have 1 letter. We can figure out what x is just like last time. Okay, what's 1/2 squared? A half times a half.
A whole.
A fourth. Yep. Yep. A half plus a half would be a whole. Half times a half is a quarter. All right. Bring the 1/4 to the other side. X squared would equal 3/4. Just subtract the 1/4. And now I don't want to know x squared. I just want x.
I'm lost.
Well, yeah,
You can just
With
whip through some steps real quick.
No, wait, why'd you even...
Or like erase that last one you just wrote and then like start like.
how'd we get 3/4?
you subtracted 1/4 from 1.
Mm.
So we're just moving the 1/4 to the other side.
Yeah,
Yeah, I gotta like see the work.
So we're good now?
Yeah.
Okay, we're good. So x squared is 3/4. And now what do we
Wait,
do?
how'd you get 3/4? Oh.
1 minus 1/4. Joe?
You would square root both sides.
Yep. So we end up with the square root of 3. Can we do that?
No.
There's nothing we can do with that. How about the square root of 4? 2. So that's x. So x was the long side. That was the side on the bottom. So how long is it on the bottom? To go from here over to here, square root 3 over 2. It was x. And now, how tall is the triangle? 1/2. So we go right square root 3 over 2 and up 1/2. So what's the coordinate for 30 degrees? Yep.
Square root of 3 over 2 and a half.
And then 1/2. Those are the last two numbers you need to know. Okay? You don't have to go through figuring them out again. So all you have to know is root 2 over 2. That's the number with a 45-degree angle. Root 3 over 2 and 1/2. If you know those three numbers, you can do any angle you need to on this circle. So root 2 over 2, root 3 over 2, 1/2. Now, Joe, you mentioned something about a 60. So 60 degrees is up here. And now we also need the coordinate for 60. So you might be thinking we could go through everything all over again. Well, not really. Okay? The 60, if I draw this triangle in black, that's the same as the red triangle. They're the same triangle. What's the difference though? Like, yeah, you just kind of turned it and you're standing the red triangle up on the top, on the short side, rather than having the red triangle laying down on the long side. So now, this part would be how long right here? That's your 1/2. Okay? This is this. You just took the triangle and stood it up. So that part is 1/2. And then, how long is this part? That's square root of 3 over 2. This part right here is originally, when it's laying down, what was right here. So I'm just trying to show you the red and the black triangle. They're the same thing.
So you just switch the coordinates.
You just switch them. Okay, and if you forget, well, is the 1/2 the one that comes first, or the root 3 over 2 that comes first? I can show you how to figure it out.
Wait,
And that's for 60 degrees?
Yep.
For the like 30, 60, 90 triangle, does that work for 30 and 60 no matter what?
Yeah, every time. Yep. It never changes. It's always those numbers. And when you draw your triangle, if you're not sure, wait, is the 1/2 supposed to come first, or does the root 3 over 2 come first? Well, if you draw your triangle, say you're doing the 30, and you forgot which side is which. Well, the short side is always 1/2. Always. The shorter side is the 1/2. The longer side that I'm tracing right now, that's always root 3 over 2. Always. So now I can tell, oh, 3 over 2, that's my x. That's the left and right. Up and down, that's my y. That's a half. Alright, so you just have to remember those two numbers, and remember the short one is always a half. Okay, so let's try an example. Is it right here? Okay, so it's asking us to find the 6 trig functions of pi over 6. Now, what didn't they give me that I need in this case? Joe?
They didn't give you the angle, which then you can change into the. They give you the radians, so then you have to change the radians into angle, and the angle into, or you could just leave it angle.
Well, that's an angle, right?
It's radian though.
Yeah, that's like, well, saying like, well, you're used to say measuring in inches, and I measure in feet. And you say, well, you didn't measure in length. Yeah, I did. I used length. I just used feet, and you used inches. So that's still an angle. That's just radians and not degrees. So that is an angle. But what do we need about the angle? If you want to change to degrees to get where you need to get, that's fine. But ultimately, you got to get what? You got to get the coordinate. However you can get it. Okay? If you need to change to degrees, then we can do it. Okay, how do we change pi over 6 to degrees? Yep.
How would that work if you didn't go to degrees?
You would have to be able to think in your head in radians. Just like people can think in their head in degrees and visualize, oh, 30 is like a little less than halfway. Some people can just visualize pi over 6. For me, I usually like to change it to degrees. Yeah. Some people are used to working in radians and they can do it just as fast.
You have to know what degrees all the radians are.
Do I have to know what?
So like if you would do it like that, you have to know what degrees are.
Yeah, some people pretty much can just look at that in their head and they know it's 30. They just have it memorized. I guess if you work with it for years and years, eventually you just memorize pi over 6 is, well, it is whatever we're about to figure out. So how do we figure out what it is?
Times like 180 over pi.
Times 180 over pi. And then you're left with 180 divided by 6, which is how much? 30. All right.
Gave it away already.
I know, I kind of gave it away. So we know that it's a 30-degree angle. We kind of knew that before. And now I got to figure out the coordinate. I don't memorize what the coordinate is. Like if you ask me like really fast, what's the coordinate? I'd have to think about it for like a second, and then I could tell you. All right? Because what I do in my head is I picture this diagram, and I picture, okay, where's 30? Is it closer to 90 or closer to 0?
0.
It's closer to 0. Should be less than halfway. So I picture it right there. I picture that triangle, and then I think, okay, which side is the long side? Is it on the bottom, or is it going up and down? The long side is on the bottom, and what number is always the long side? Well, the hypotenuse is 1, but we're talking about the legs.
Square root 3 over 2.
The long side is always square root 3 over 2. And then the short side is the height, and how long is the short side? 1/2. Now, x and y. X is root 3 over 2. Y is 1/2. And the more you practice it, the faster you get at doing it. It's the only way to get fast at it. Okay, and this time they do want all 6. Okay, on the test, I'll just ask you for one of them. But we'll practice all 6. So let's start with the sine. So what's the sine of pi over 6? Okay. It's 1/2. It's my y value. So there's my sine. What about my cosine? Square root of 3 over 2. That's my x. Now, how do I get the tangent again? We don't have to do the final answer because we might have to reduce a little bit. Y divided by x. 1/2 divided by root 3 over 2. And again, I don't even memorize what that is. I don't know what it's going to come out to. I'm just going to figure it out. If I tried to memorize all 6 of these, that's way too much to memorize. All I know is these 2 numbers. Those are the only 2 numbers I memorize, and from there I just figure out whatever I need to. Would it be faster if I had all 6 memorized? Yeah, then you could just instantly write down the answer to any of them without doing any work at all. But that's a lot of memorizing. So here, what's going to cancel? 2's. So now you're left with 1 divided by the square root of 3. And how do we fix that? Yep.
Multiply by square root of 3 over square root of 3.
Multiply by square root of 3 over square root of 3. 1 times the square root of 3. And then in the bottom, what's the square root of 3 times the square root of 3? 3. Okay, so I circled the final answer, but don't erase or cross out any of the work we did because that's going to help us to get cotangent faster. Okay, all the work we have right there. So we'll come back to that. All right. What about cosecant? What's that one? 2. Flip 1/2. How about the secant? What's the secant?
I think I would use square root of 3 over 3.
Yeah, let's just do it in 2 steps. Step 1, flip it, and then he fixed it at the same time. He multiplied top and bottom by square root 3. So 2 square root of 3 over 3. Now, cotangent. So I'm going to circle 2 things. I'm going to put a dotted circle around that one. What I have circled in black and in red, they're the same number, right? Because they're equal. That's why there's an equal sign there. They're equal to each other. The only difference is one has a square root in the top, one is in the bottom. So to get the cotangent, since they're both equal, we could flip either one of them. Which one should we flip? Yeah, we should circle the one that's circled in black. How come?
There's a 1. So it's easier than the one that was on the bottom.
I thought you said it came up to just 3.
This tangent is square root 3 over 3.
I thought you said it came up to just 3.
Nope. Nope, final answer is what we circled right there. So which one, so can you say again why you would flip the black one?
Because when you flip it, the one will be on the bottom, so it's just square root of 3.
Okay, that's true. The one would be on the bottom. More importantly, what's in the top? The square root. If you flip the red one, you're going to throw the square root back in the bottom. You're going to have to fix it all over again. And when you fix it, you're going to get the exact same thing as if you just flipped what's circled in black.
So you don't have to like flip your final answer every time?
Well, if you want to get the ones on the right, you have to flip whatever is on the left.
Yeah, but why did you just flip the one that like was before you got the final answer?
So why did I flip the one that was before the final answer?
Because it's equal to it, and the square root's already on the bottom, so when you flip it, it's going to go on the top.
Right, these two things are equal to each other. Right? This was the final answer, and this was what we had when we were in the middle of doing our work. If I flip the final answer, look what happens. I get 3 over the square root of 3.
Yeah,
and that's correct, but I have to fix it all over again. And if I fix it, watch what I get. Multiply top by square root of 3, and bottom, I get 3 times the square root of 3 over 3, and then what cancels out?
3.
The 3's. If I had just flipped what I had right here, I'm done
Alright, that makes sense.
in one step.
Right.
Yep. You don't have to do it that way, it's a little faster. Okay. So on the test, something like this would be 6 separate problems. Okay, it wouldn't all be in one question like that. Any question on those?
Would it all be about the same one though?
No, each one will be a different angle. Like I'll say, find the sine of pi over 6. Find the cosine of 90. Find the tangent of 60. So there'll be different angles.
So we get a paper again?
What's that?
We get to like make a paper again?
For this one, no.
Alright.
No. So the 3 things you have to know for the test, you've got to know that coordinate for the 45. You've got to know this coordinate, and you've got to know that coordinate. Now, the top one is the 45. That's easy because it's all root 2's. This one is when x is the short side, so that's the 60. And this is where it's laying down, x is the long side, and y is short. So that's the 30. See, that's how I have to think about it. Each time, I just kind of visualize that triangle in my head. Yeah.
So on the test, you're just going to ask us the sine, cosine, tangent, and the other ones?
Yep, and then there'll be some calculator questions we're going to do tomorrow.
Okay.
But yeah, there's like 13 or so of these kind, like find the sine, find the cosine, find the secant, and then a few calculator ones. And then that's pretty much it. All right, so we just did pi over 6, which is 30 degrees. Let's try, get rid of that. Let's try 60 degrees. Now, we just did 30. What did we say the difference was between the coordinate for the 30 and the 60?
There's a flip.
You just change the x and the y. So you're going to get all the same answers here that you just got before, except they're going to be in different spots because the x's and the y are switched.
So for that, like say we were to like memorize, we can just take like the 1/2 and square root of 3/2 and just go with that.
So that's your first step. Does everyone see how he got that? 1/2. He said 1/2 square root 3/2. If you're not sure how he figured out the 1/2 is first, or how I would figure it out, is I would go like this, make a circle, put 60, not all the way towards 90, but just put it up kind of close to 90. Make a triangle just like that, and now look at it. Here's the short side. Short side is always a half. And here is the long side. If you draw it reasonable, I mean, it's pretty obvious which side is short and which side is long. So now I know my short side is my horizontal, that's my x. The tall side, up and down, that's my y. You just have to know 1/2 and root 3/2. You got to remember those two numbers. Okay, so give that a try. See if you can find the 6 trig functions for 60. And yes, you could just look back at 30 and copy the answers down and put them in different spots. But keep in mind, on the test, you might not have done the 30 yet, so you'd have to still figure all of them out. So I would try just figuring them out. All right. So as you went through it, if you did everything correct, you should notice kind of all the answers that we had before, just in different spots. So let's start with the sign. How about Mike? What's the sign?
Square root. Square root of 3/2.
Yeah. So we get square root 3/2 because it's the y value. Derek, how about the cosine?
1/2.
Yep. Cosine is a half. And now the tangent, I'm just going to erase this, is y divided by x. Okay, when you divide those two fractions, what cancels out? The 2's are gone, and all you're left with is square root of 3. Now we flip everything to get the other ones. So what's the cosecant of 60? 2 square root 3/3. How about the secant of 60? 2. And the cotangent of 60?
Square root of 3.
Square root of 3/3. Because when you flip this, you'd have 1 over the square root of 3, but then you got to fix it by multiplying top and bottom by root 3. So let's take a look and see. Let's see what happened. So, does anybody see 2 trig functions where the answers switched places? Skylar? The sine and the cosine. Those 2 switched. Okay. What other 2 switched? The tangent switched places with what did the tangent switch places with? The cotangent. So the tangent switched places with the cotangent, and then what other 2 switched? The cosecant and the secant. Now, if you pronounce those, the ones that are in the boxes, you should notice kind of a pattern. Sine, cosine. Secant, cosecant. Tangent, cotangent. So these are called co-functions. Sine, cosine. Secant, cosecant.
Do we need to know that?
Tangent, cotangent.
Do we need to know that that's
What
involved?
angle?
Not this week. Next week.
Wait, what degrees is on the left side?
That was 30. So these were all the 30s on the left, and on the right we did 60. So with 30 and 60, I'm just showing you everything changes places with x and y.
Why is it cosecant and then secant, but all the other ones is the other one, like the first one before them? Like, it goes sine, cosine. Why does it go cosecant and then...
Oh, just the way it's written? I don't know, it's just the way the trig functions are defined. It's more of just a definition. Yeah, it's kind of like saying, why don't parallel lines cross? It's just kind of the way it's defined. Unfortunately, yeah, that's the way it is. All right, so let's take a look at, I want you to look at this picture. What angle is that right there if it's halfway between 0 and 90? It's a 45. And what's the coordinate for 45? Square root 2 over 2. Square root 2 over 2. Now, let's say we're at 90 and we go 45 degrees past 90. What angle would we be at if we add 90 and 45? 135. Now, put a triangle right here. That's what we've been doing today. Well, we'll do the same thing. Put a triangle right there. If you look, and I'll make them different colors. Look at the triangle in black, and look at the one in red. And do they look similar? Does anyone notice anything about them? They're the same. It's just like a mirror image. It's a mirror image. That's all it is. So this side is still square root 2 over 2. This side is still square root 2 over 2. The only difference is you went left and up instead of right and up. So if you went left, what kind of number should the x value be? Negative. And if you went up, what kind of number should the y value be? That's still positive. So tomorrow, when we look at doing a 45-degree angle in any of the other quadrants, it's exactly the same two numbers. The only difference is sometimes there's a negative in front of the number. Other than that, everything else is exactly the same. And it's the same with the 30s and the 60s. Sometimes there's a negative in front, depending if it's outside of quadrant 1. So we'll look more at that tomorrow, and then we'll also do the calculator stuff tomorrow. All right. Okay, so the homework tonight, there's 10 questions on the worksheet, and then there's 5 up here. Some of these are review from yesterday. You've got a little room at the bottom of the worksheet. You could do those on it, or if you want to put them on a separate sheet in your notes, that's fine too.
Can I